This is the second lecture on converting ER diagrams into tables in a logical database design. The previous lecture covered the conversion of entities and one-to-one binary relationships from an ERD to a logical database design, and in this lecture we'll cover the other types of relationships. In particular, on completion of this lecture, you will be able to convert one-to-many, many-to-many, unary and ternary relationships. To convert a one-to-many relationship, we make the primary key on the one side a foreign key on the many side. Thus, in the example below, there is a one-to-many relationship between salesperson and customer to encode the business rules that a salesperson can sell to any number of customers and that the customers must have sales with exactly one salesperson. We encode this by adding the primary key of salesperson as a foreign key to customer. Note, if we did the opposite and made customer number a foreign key in salesperson, the foreign key would have multiple values. To convert a many-to-many relationship, we create an intersection entity, an intersection table, also called an associative entity, with a composite primary key consisting of the primary keys of both parent entities. Note that the two fields in the primary key of the intersection entity are also foreign keys. So, to convert the many-to-many sales relationship below, we convert the entities as we would normally do, but we introduce a third table, salesperson, product, or whatever you want to call it, whose primary key consists of the primary keys of salesperson and product, and whose other attributes is the intersection data associated with sales. Now, composite primary keys can be difficult to work with, and the preferred design is therefore to create a made-up primary key for the intersection entity, as we did below. To convert one-to-one and one-to-many unary relationships, we add the primary key of the entity as a foreign key in the same table. We of course rename the foreign key to preserve the uniqueness of field names. The slide contains two examples of unary relationships. The left represents the rule that every salesperson must have exactly one backup and must be the backup of exactly one other salesperson. The right one represents the rules that an attorney can mentor any number of attorneys, including none, and that an attorney can be mentored by at most one other attorney. The solution in both cases is to add the primary key of the table as a foreign key to that same table. The conversion of many-to-many unary relationships is a combination of the conversion of many-to-many relationships and the conversion of a unary relationship. As with a many-to-many binary relationship, we introduce an intersection entity, but we use the primary key of the entity and a copy of that key in the intersection entity, as well as any other intersection data that may have been associated with relationship. So in this ERD, in which the relationship encodes the business rule that the product can be part of any number of other products and that the product can be made up of any number of other products, we introduce an intersection entity, bill of material or whatever, whose primary key consists of the primary key of product and a copy of that key and the intersection attribute quantity. Moreover, as we did before, we can of course also introduce a made-up primary key for the intersection data, a solution that is actually preferred, as we did in the second case. The final type of relationship we cover are ternary relationships, or in fact, any n-ary relationship. Ternary relationships map to four tables, namely one table for each original entity and one table for the intersection entity. Thus, in the example below, which we saw in the previous module, and which represents the rule that the client retains an attorney for a case, we introduce three tables, one for each of the entities, and a fourth table for the relationship, whose primary key consists of the primary keys of the three entities. And of course, as before, we can introduce a made-up primary key for the intersection entity, as we did again in the second example.